I'd now like to welcome on screen Dr. Junjie Li, Chief Expert of the Optical Transport Network from China Telecom.
Ladies and gentlemen, I'm very happy to see you online and have this opportunity to give my presentation. The topic of today's event is about broadband communications. Exactly because of the popularity of the broadband worldwide, we can meet remotely through the internet, even under the travel restrictions. Today, I'm going to introduce China Telecom's all-optical networking tool strategy and how it enables the sustainable development of our broadband services, followed by our expectations about WBBA in the end. At present, the digital economy has become the critical role globally. Broadband network has become a very important part of digital information infrastructure, and also the key foundation for creating digital competitiveness. This slide shows the study of broadband popularity worldwide from Omidyar early this year. This study qualified the level of broadband development for each country by two indexes: broadband penetration rate and optic fiber permeability rate. We can see both these two indexes are quite different among countries and regions. Good news is that the global average of both reaches 63%, and the East Asian countries like China, Japan, Korea ranks the top of the world. But we have seen that there are still many countries showing that their index is less than 40%. Some of them are even lower than 10%. I suppose that it's one essential mission for WBBA to promote the popularization of broadband all around the world, especially in those underdeveloped areas or countries. In the past 3 decades, China Telecom has made great progress in the development of broadband networks. Now, we have 177 million broadband subscribers. Among them, 98% are using fiber access. Our 10G-point facility has covered more than 300 cities, and more than 96 million users have home Wi-Fi coverage. According to our statistics and forecast, the capacity increased with CAGR for 23% from 2010 to 2030 in our backbone optical networks. But we are still facing 3 challenges to maintain sustainable development of broadband networks. First off, higher bandwidth. Cloud network convergence is reshaping our network. There are more and more video apps in our smartphones. The resolution is going up and people spend a lot of time on them. 4K, 8K facilities gradually enter thousands of houses. The steady commercial use of AR/VR and the concept of meta-universe, all these emerging technologies and services have constantly put forward higher requirements for transmission bandwidth. Secondly, lower cost. As network operators, we must continuously reduce the cost per bit to meet the user's affordable demand for the bandwidth in this bandwidth explosion area. We must reduce both the CapEx and OpEx. And OpEx may be more critical because total OpEx is estimated to be 3 times of CapEx for broadband networks if we analyze the TCO, total cost of ownership. The third one is lower power consumption. Green telecommunication stands for the future, which is in line with the global target of sustainable development for all human beings. China government has claimed the goal of emission peak in 2030 and carbon neutralization in 2060. All optical network, shortened as AON, is a solution proposed by China Telecom to meet the above challenges. The emerging stage of AON is from 2000 to 2007. We used both copper and fiber as the transmission media. Backbone and metro networks took the lead in using optical fibers, but the access network still mainly used copper wire. Then we entered AON 1.0 stage from 2008 to 2017. Changes came mainly in access layer. Optical fibers were widely deployed to replace copper wires. The third stage is from 2018 up to now. That is AON 2.0. Our optical access technology is further penetrated. Our optical transmission technology constantly increases both bitrate and capacity, introduces the new optical fiber and exploits new spectrum. The most significant progress is introducing ROADM-based optical switching technology. In addition, there are some new changes referring to network architecture and intelligent operation, which will be talked later. The target architecture of AON2 in the year of 2030 is a flatter network. National and provincial backbone optical network will be merged into one unified backbone network. Metro and access network will gradually converge together. In short, a simplified two-layer optical network will replace the current four-layer network. To be noticed that wavelengths will become the essential element of all optical transmission and the switching network. OTN and further OSU technology will enhance the capacity at sub-wavelength layer. PON and other optical access technologies will be developed from 2C to 2B scenarios. Meanwhile, the unified control of cloud and network is another important goal. New technologies such as SDN, telemetry, AI are planned to adopt in the new OSS system for more intelligence. Open and disaggregation of optical networks will be another hot topic and be introduced step by step. Now I'm going to show some new technologies and deployments of AON 2.0. First off, the foundation of the optical network, high speed and high capacity transmission. Now we plan to introduce single wavelength 400 gigabit per second system, which can experience 3 generations. The first generation used 16-core modulation format with symbol rate about 60 G-band, but is limited by transmission distance and is more suitable for short-distance applications such as 400ZR. The second generation has applied the probabilistic constellation shaping 16-core. The symbol rate reaches about 90 G-band, and the maximum transmission distance is close to 1,000 kilometers without regeneration. The third generation will further increase the symbol rate to about 130 G-band to make sure the system can use QPSK modulation format with high performance, so it can support actual long-haul transmission distance of nearly 2,000 kilometers without regeneration. Although we have increased the bit rate of each wavelength from 100 to 400 in recent 10 years, but we haven't achieved the corresponding growth of capacity, so we are working toward this target via several innovations. The first innovation is to expand the new spectrum, specifically introducing the extended to the C-band and the L-band. The total capacity can be reached at 11 terahertz or even 12 terahertz with the use of 400 gigabit per second DWDM system in future. Critical changes for L-band optical amplifier comes from new fiber gain media, noise field control, and nonlinear effects like SRS. Another innovation comes from optical fibers. Single-mode fiber-based innovation has been considered first in order to be compatible with a large number of single-mode fibers under deployment. It has been proven that lower loss and larger effective area are two effective methods to improve the transmission performance of fibers. China Telecom has taken the lead in deploying ultra-low loss and large area G.654.E fiber in terrestrial optical cables. The world's first all G.654.E national backbone optical cable has been put into operation in the year of 2021, connecting Shanghai and Guangzhou. In the backbone network, China Telecom has fully applied optical switching network based on ROADM. The network has more than 460 ROADM nodes, over 800 terabits per second total bandwidth, and more than 3 million kilometers fiber links. It covers over 340 cities and all major data centers nationwide. Based on this ROADM network, we provide the capacity of rapid wavelength provision in minutes, quick failure recovery in seconds, and lower latency. For the metro networks, our optical network tools take actions to extend the optical network technology like WDM and OTN downward to central office. One driving force comes from the continuous bandwidth growth due to the development of both fixed and mobile broadband services. The number of metro bandwidth has reached at several hundreds of gigabits per second, and the WDM is an ideal solution for saving optical fibers and managing the bandwidth. On the other hand, not all the customers require bandwidth in wavelength granularity. We must provide sub-wavelength fine granularity services with high QoS. China Telecom works together with partners to put forward the metro OTN with OSU containers as a key technology. Comparing with the legacy OTN, OSU enhances the bearing efficiency for small granular services, but is still compatible with traditional OTN via ODU layer. Now let's move to the topic of WBA, World Broadband Association. As a founding member, China Telecom has great expectations for WBA. We really hope that WBA will provide benefits to broadband network operators, service providers, cloud service providers, and other related stakeholders in the world. It will also play an important role in combining the global industry chain, promoting and strengthening communication and cooperation among the industry. Dear friends, currently we are entering the emerging digital economy area. The broadband industry is facing the opportunities and challenges, and we hope we can grow up together with WBA. We sincerely wish to see more and more partners can recognize and join WBA, and to create a better future and a wonderful world under the cooperation of all of us. Thank you very much.